In this work, we examine how we can acquire full body motion of an actor using multimodal input data. In this example, the motion of a tennis player is synthesized using the input data from a single triaxial accelerometer attached to their right forehand, plus global position and orientation information. Our approach is to create a motion graph that adequately describes the movements that an actor is expected to perform at capture time. This graph is tailored to the type of input data modalities that are expected to be provided. At capture time, synthesized motions are obtained by searching for paths through the motion graph that would produce data readings to those obtained from the subject. This approach can be used to augment the use of traditional optical motion techniques in difficult capture environments and application scenarios. Such scenarios include capturing actions in large spatial volumes, outdoors, or at competitive sporting events. The approach is portable and unobtrusive. In this illustrative example, we synthesize the motion of a boxer using just 2 accelerometers, 1 accelerometer per wrist. In all examples, the ground truth motions are removed from the motion graph before synthesis. As such, synthesized motion cannot come directly from the ground truth captured motions. In this example, we use data from 6 wireless accelerometers on a tennis player's body. The devices are placed on the player's wrists, shins, their chest, and the lower back. Accelerometers are lightweight and unobtrusive and therefore can be used with minimal impact to the performance. Although the approach captures relatively accurate motion in terms of the athlete's torso and limbs, their global position and orientation can drift. This drift occurs because acceleration values alone are not sufficient to determine the subject's root position over a significant period of time. However, if root position and orientation are available, we can extend the algorithm to efficiently utilize this data. Unlike previous approaches, only a small linear increase in computational complexity and space requirements is required to incorporate this data. This allows us to synthesize motion using both long sequences and large motion graphs. In this example, a sequence of over 10 minutes in length is synthesized using a motion graph with over 140,000 nodes. This was achieved with a single pass of our search algorithm. The approach can be adapted to synthesize motions from 2 or more heterogeneous input modalities. In this example, using just positional data can result in poor synthesis of an actor's motion. This data could be obtained from additional wearable sensors, such as GPS and magnetometers, or external sensors, such as cameras. The addition of accelerometer data ensures that good local body motion is also obtained. Even though the animation deviates from the required global position path in order to kick correctly, a quick recovery to the correct global position is made. In this example, the motion acquired from 6 accelerometers drifts over time. Incorporating weighted global data significantly increases robustness to drift. In addition, the use of global position and orientation data allows the number of accelerometers used to be decreased without affecting performance. The positional data replaces the need for the additional devices, as it significantly reduces the ambiguity of the player's motion between shots. In this example, an improvement in boxer orientation error can be seen by incorporating global orientation data into the approach. When global orientation data is also included as an input data stream to the algorithmic process, periods of synthesized error for the accelerometer-only motion are removed. In this example, regardless of the input modality, inaccurate athlete motion is synthesized during the second tennis stroke. By utilizing global position data, these errors can be quickly removed without significantly compromising on the accuracy of the motion of the player's body and limbs. This is not the case for an accelerometer-only approach.